So this is problem 12.3. And this problem is a little bit different in that instead of trying to find the ultimate bearing capacity, we need to find out what the embedment depth of the foundation is, given a bearing capacity. So this is an especially good problem for MathCAD. I'll show you how it can be solved pretty simply. So again, I use the snipping tool in Windows. I cut and paste the problem. Here's my givens, my width of foundation, my length, the factor of safety. C, the cohesion is 1/2 of the bearing capacity, and that has to do with the Moore circle when you run the unconfined bearing test. Ask me about that in class, and I'll explain that. But the cohesion is 1/2 the unconfined compressive strength. Gamma, this should actually be gamma sat. So let me fix that. So gamma prime is equal to gamma sat minus 9.81. So here we use a MathCAD solve block. Let me click this button and go from page view to draft view, which spreads out the sheet a little bit. And the way you input a solve block is that you click this little button and it introduces the solve block. Let me delete that and go back to the page view. So the way it works is that MathCAD will iterate through a solution. So if you make a guess at the value that you're looking for, and this time I just said, okay, let's assume d sub f is 2 meters. Then I put my constraint, which is basically my equation, that I want to find the value of ds that makes this a true equation. Because it's a true equation that I'm looking for, I use the Boolean equal sign, which is the control equal on the keyboard. So if I wanted to, I could say Q control underscore U and then hit control equal, and that gives me the Boolean equal sign. And then I have just type in a variable. I've called this one solution. There's a find function in the solve block. It finds the value of d sub f that makes our constraint a true equation. So this is a linear equation that only has one root. If there was a couple of roots, it would give you a vector that had two answers in it, and you'd have to figure out which one was the correct one that you're looking for. Also, I can type in the equal sign, and I can use this value outside of the solve block. So this is the answer to problem 12.3.